I welcome every participant. Yes, someone wants to say something. Okay, so I'll start sharing my screen. Let me know when you guys can see the screen. I hope you can see the screen now.
Yes, sir, now it is visible.
Okay. So today, actually, I have given two topics. One is for microgrid, AC microgrid, another for eBus. I have been following the last 2 days sessions that is related to renewable energy and different converter topologies. So I thought let's take a break from converters and converter topologies for renewable energy. Let's jump into something interesting, that is eBus and charging. And tomorrow we'll continue again with microgrid, how to integrate different AC sources to a microgrid and how to control that. That is about tomorrow's topic. Okay, coming to today's topic. Today I'm going to discuss flash charging technology solution from ABB. So where I was part of this particular product when I worked with ABB for the past 2 years. So coming to this technology that is called flash charging technology, which can enable a new generation of electric buses. Okay, the moment I say electric buses, so everyone will think of few questions. For example, I'm an operator. I have 100 diesel buses that is required for me to take care of my demand from the passengers to meet the demand. Now, if I want to convert all these diesel buses into electric buses, do I need to purchase just 100 electric buses and 100 chargers? Is that fine? Is that enough for me to handle the same demand? Or do I need to purchase 120 buses or 150 buses? You know why? Because the bus needs a huge battery and it needs some time to charge. So whatever the number of buses you purchase, that needs a considerable amount of time to rest at a particular place for charging. So the replacement factor between the diesel buses and electric buses would be like 1.2, 1.5. Sometimes people are saying about 2. So you need to purchase 200 electric buses. So that is one issue there. So you need to invest a lot. And second thing, coming to batteries, like how long the batteries can survive, maybe 3 years, 5 years. What happens to that after that? Then few more questions, something like, okay, what about the charging infrastructure I need to install and how it will impact the grid? For example, there is a existing grid in the city, and if I want to bring electric buses, will that be enough for the existing electric grid, or do I need to increase the capacity of electric grid? So we'll see all these things one by one. How to address all these issues with flash charging technology, that is what I'm going to cover today. So basically, I left ABB and joined NIT Surathkal. However, this presentation belongs to ABB, so the logo stays here as ABB. And I would like to thank ABB for letting me to use this material to share the knowledge of flash charging technology. So let's jump into our discussion. So to convert any diesel bus into battery powered vehicles or e-bus, there are different solutions available in the market. So we'll start with well-known technologies. Okay, before that, let me tell you about some terminologies. Some terminology is something like depot. We all know. So depot is the place where at the end of the day, all the buses go to a particular place called depot. Okay, so you can charge there. That is what called overnight or depot charging. So here you generally have charges rated from 50 kilowatt to 150 kilowatt. Okay, so then it needs a charging time of 6 hours to 8 hours, 6 to 8 hours. Okay, now let's come to something called opportunity or terminal charging. So what is terminal? Let's understand the common terms. So for depot, we know that it is the resting place for all the buses. Now terminal is, let us consider a city which has two main stops. Let's say the bus has to run between airport and city center. Let it be any city center. Okay, so the terminal is airport is one terminal where you have some time to rest, like 3 to 6 minutes to start the next trip from airport to city center. So 3 to 6 minutes you can rest there. So in that 3 to 6 minutes, why don't you charge? So that is what called terminal only charging, terminal charging. Okay, so where you install a high power converters, roughly around 150 kilowatt to 600 kilowatt charges will be available there. In that 3 to 6 minutes, you charge the bus again. Okay, now between these two terminals, between the city center and airport, there will be, like, let's say some 30 number of bus stops are available. Okay, so that particular bus stops are there where the passengers will get in and get out of the bus. So flash charging technology thought about, why don't you charge when the passengers are getting in and out? In that instant, let it be 10 seconds or 20 seconds or 30 seconds. Why don't you charge that? So we'll see how we can charge in that short period of time and why it is required. What is the benefit you get out of that? Okay, so these are the things that we are going to discuss today. And again, so different solutions, like let's say third, number three is overnight charging, may be beneficial for low capacity and low frequency buses. I mean, let's say length of the bus is 7 meter, 9 meter, less than 12 meter. It may be beneficial in the terms of economical. So for every trip, for every route, you have to do a techno-economic evaluation. So what is the technology that you want to use and how far it is suitable for that particular route? So again, I'm not saying only the number one solution is the best solution. The number one solution may be best if the bus length is much higher and you don't have much time to rest. I mean, if it is city center to airport, you have to continuously run the bus at least for 18 hours in a day. So you have only 3 hours to rest. So in that kind of scenarios, this kind of technology would be much beneficial. So technically it is called as high frequency, high capacity bus. Now, what is the impact of these different charging technologies? So you say that you can charge here and there. What is that I'm going to get? So let's look at first battery. So if it is only depot charging, that means you are charging the bus at only one place, that is depot. So let us consider the bus has to come out of the depot and has to run for whole day from morning to evening. Let us assume that it has to cover 300 kilometers in a day. Okay, so my bus should have the battery to support this 300 kilometers. That means I have to carry a huge battery with me so that I can cover 300 kilometers in a day before I go back to the depot. So that is how you end up in more than 450 kilowatt hour battery capacity that you have to carry, which weighs more than 4.5 tons. And I have seen few brochures from different companies. It says the total weight of the bus is 13 tons. See, imagine. So if the weight of the bus increases, and force is mass into acceleration. So if the mass increases, the energy required to make the bus move also increases. So again, you need to carry more. So the more the weight you carry, the more the energy you consume. And what about the passenger capacity? Because you are already carrying a dead weight, how many passengers that you can carry? If you carry more passengers, at least you will get some money. They'll pay. So that is called payload. Okay. So that is one thing that you need to note about depot charging, the impact of batteries. Now let comes to terminal charging. You are charging the bus at three locations. One is at depot and two more instances at two terminals. Okay. So at the end of every trip, you have 3 to 6 minutes and you are going to charge with a power of 200 to 600 kilowatt. So since you have some energy supply now and then in a day, you don't have to carry a huge battery bank. So that's how you can reduce a huge amount of battery that you carry. And that's how you reduce the weight of the battery, that is the dead weight, which doesn't pay you. Okay. So this is about the second one. Then When it comes to the third option, similar thing is happening. Instead of charging at 3 locations, you are charging at more locations. So the energy top up has increased, and hence you can further reduce the battery that you are carrying. So you can carry a very lightweight battery so that you can increase the passenger capacity, and also you can reduce the energy that you consume. The energy in the sense, the amount of energy that need by the bus to move for 1 kilometer. That is what generally called as watt per kilometer, watt hour per kilometer. So generally it is assumed that for a 12-meter bus, it is 1.5 kilowatt hour per kilometer. That means to make the bus move for 1 kilometer, you need an energy of 1.5 kilowatt hour. Okay, so that's how all these calculations, 300 into 1.5, it will be 450. Then the first case, why it should be greater than 450? Because you cannot completely discharge, so you should have some reserve so that you can go back to the depot. So it should be more than that. And also generally, industry takes care of safety and derating, because when the battery is very new, you can have that capacity, but the battery aging goes on, then you have to see the full life of the battery, and then you have to purchase the battery size. So generally it should be more than 450 kilowatt hour. So this is the impact of amount of battery that you carry with respect to 3 different technologies available. Now, one more thing that you need to note here is, when you go with first technology, that is depot charging, you have to wait at the depot for more than 6 to 8 hours. 6 to 8 hours you have to wait at the depot. So your bus cannot run at least for 6 to 8 hours in a day. But when it comes to the second and third options, you can reduce the amount of time that the bus can rest. That means you can reduce the number of buses that you want to purchase. Now, again, the solution can be depending on multiple factors. We'll see one by one what are those multiple factors. Okay. Now, the moment I say you have to charge the battery at different instances, everyone will ask me, what about the life of the battery? You are charging the battery like different instances and you are discharging it. What about the life of the battery? Okay. So as we all know, the life of the battery depends on two factors. One is how deep you discharge. The second thing, the style of charging, the way you charge it. Okay, so let's see how deep the discharge is happening in 3 different technologies. So as I said, in overnight charging, you charge at only one instant. Let's say you start with 100 SOC, then finally at the end of the day you reach 10% or 15%. So the depth of discharge is around 15% or 10%. So more the depth of discharge, lesser the battery life. You take any chemistry of the battery, this is valid. Second, second technology, that is opportunity charging or terminal charging. At the end of the day, when you reach your depot, it may be better than the previous case. So the depth of discharge can be limited to 30%. So still, the second case would be have better life than the first case. Now, when it comes to the last technology, that is flash charging technology, we generally limit the depth of discharge above 50%. Let's say 55% or 60%. So with this, when you compare the life of the battery with the first technology, which can go as deep as 10%, and compared to the last technology where the charge doesn't go below 50%, the life of the battery can be the same chemistry. Let's take the same chemistry. It will be more than twice. For example, the first one gives you 5 years of lifespan. The last case can give you more than 10 years of lifespan. Okay. I'm saying the depth of discharge is limited. That's how you can increase the lifespan. And again, I said one more thing, that is the way you charge it. Let's talk about that. What is the style that you have to charge the battery to even further increase or better utilize the charging rate? Okay, any battery has a rating called C rate. Okay, that is charge or discharge rate. For example, 100 ampere hour battery, the C rate says 1. That means in 1 hour, you can take 100 amperes, maximum of 100 amperes at any instant. For, for example, if the C rate is 2, that means you can discharge, you can take out 200 amperes or you can give in 200 amperes. So uh, again, one more point that you need to note with respect to C rate, the fast charger or slow charger doesn't make any sense. Fast or slow depends on the C rate of the battery. The only charger, whatever you're talking in the industry or in papers, it is just a power converter. Okay, whether the battery will allow you to charge faster or slow is what fast charging or slow charging. Okay, so if the C rate is higher, then you can charge that battery much faster. Okay, so that's how it links. Now, whatever may be the C rate, any chemistry, take any chemistry from 0 to 15 or 0 to 20, you have to slow down your charging. Though the C rate is 2 or 3, you cannot use that C rate at this percentage of charging. When the battery is around 0 to 20 or 10 to 20, you cannot completely use that C rate. For example, if the battery is able to take 300 amperes at any instant, then you cannot make that 300 amperes pump in when the state of charge is this one. So that is why you have a different charging techniques, that is constant voltage and constant current, CT, CC, and constant temperature, whatever it is. Take anything there, you have to slow down your charging in this area, that is 0 to 20, and again at 85 to 90 or 90 to 100. So the rating may be the values, what I'm saying, 85 to 100, 0 to 20 may vary, depends on chemistry, but the conclusion is you have to slow down your charging at this area and at the top area, but in between you can charge it as fast as possible. Fast as in the sense you can inject more current, you can utilize the C rate properly. So that's how we plan to use this two things. We limit the depth of discharge, and also we don't go above 90 percentage or below this percentage where you have to slow down your charging. So that's how. Let's take a trip. So you are starting at a terminal with 85 percentage. You go for 3 bus stops without any charge. At 4th bus stop, you have a little charge again. Then you go with 3 bus stops. That's how you reach the other terminal with a percentage of 60 percentage of SOC. Then you have 3 to 6 minutes of time. Remember, at any terminal, at any terminal, you have 3 to 6 minutes. That is decided by the operator. He can say, I can only stop for 3 minutes. I can stop for 5 minutes. He can say sometimes I can only stop for 1 minute. Based on that, the number of instants that you need to charge will change. So again, the chargers that you install in a route is completely route specific in that route. So what is the energy that you need for that bus to complete one trip? Based on that, the charging locations and the battery capacity will be decided. But it's not about the bus, it's not about the amount of charging chargers you provide. It's completely route dependent. It's not about bus dependent. Okay, so that's how you start with 80 percentage. At the end of the trip, you charge it again with whatever the given time you have, and you are ready to go again to the next trip. So the conclusion here is the life of the battery can be more than 10 years. It is expected to be more than 10 years. The proof for this is the first bus with this technology delivered in Switzerland, city of Geneva. It is delivered in 2013. It is now 2020, roughly 7 years. So far, no bus has come and saying that the battery has gone its life and we need to change. So it is still running properly. They are still able to maintain this depth of discharge and the style of charging profile shown here. Okay, that's how you handle the life of the battery. Now, will someone will ask me like, okay, in earlier case I have 100 buses and 100 chargers. Now you are asking me to install chargers at different locations. Okay, to answer that, we'll see how the infrastructure cost will be reduced. Before that, let us see that In particular, this route, for example, to meet the requirement, there are 15 buses required. 15 buses required, not one bus, right? So if the one bus start from one terminal, let's say I'm a passenger staying at one particular bus stop. Let's say I'm staying at this particular bus stop. I missed one bus. Okay, I cannot wait for the next bus until it completes the full round, right? So I need more buses running in the same line. So I can expect the next bus in 1 minute or 1.5 minutes or next 2 minutes. So you need at least 12 or 15 buses to make this possible. So for the 12 buses or 13 buses, how many chargers are installed here? One at the terminal and one more at the other terminal, the two, and here it is 3, 4, 5, 6, 7, 8, 9. Only 9 chargers are required for 12 buses. So I'm reducing the infrastructure. Yeah, and further, we are still optimizing that the way we use the converters, existing converters. So let's see what happens on the bus, on board bus. You have the battery and you have the motor drive, which is a three-phase IGBT converter. Three leg or four leg. Generally, it will be four leg because there will be braking chopper. So there will be four leg converter available on your board, on board. Now in conventional, what they do, you get the power from the grid and you install a charger. So a charger is nothing but a rectifier and a DC-DC converter. They use different technologies. Whether they use line frequency, they don't use any high frequency DC-DC converter, because any country needs isolation. So whether they go with line frequency or they go with high frequency transformer, you have different topologies to use that. Basically, you need a rectifier and a DC-DC converter. So now what happens? This charger will directly charge the battery and you are not utilizing this four leg IGBT converter on board. But in flash charging technology, we plan to use this converter, which is not utilized while charging. So we make this power electronic converter to do this DC-DC operation so that you don't need to install a charger. Actually, you can just install a rectifier which can maintain the DC bus. So it is like a plug point in your home appliances. So you have a plug point, you go and connect your laptop charger, it will charge your laptop. You remove the laptop charger and you connect your mobile charger, yes, it can charge it. So it is just a plug point. We're just installing a rectifier but not a charger. So the charger is available on board, which you have already purchased. When you purchase a bus, you already purchased this converter. So why to invest again on a DC-DC converter to charge your battery? Why don't you use the same thing? So that's what we are doing here exactly. So, but to convert this three-phase inverter into three-phase DC-DC converter, you need some components that is like very simple in power electronics. You can do that. Now, my contribution in this is particularly with respect to this rectifier. When I say you need to maintain constant DC voltage source and to meet the grid code, what is the grid code? The percentage TST of voltage, percentage TST of current should be less than 5%. And the DC bus regulation should be maintained here, 500 volt, when the bus is there and bus is not there. So generally you choose IGBT converter. That's what happened in ABB as well. So they choose IGBT converter. But I was asked to look into this converter because this is quite expensive. Expensive, and let's say a 400 kilowatt IGBT rectifier will cost you around 32 kilo Swiss francs. I mean, more or less US dollars, 30, 32 $1,000. Okay. What I did is I have come up with a new topology that is thyristor based, which can meet the grid code without using any filters, either passive or active, no filters, absolutely no filters. But with thyristor, by controlling the thyristor, you can maintain the grid code and maintain the DC bus regulation, which will reduce the cost by 4 to 5 times. And which is what the Europe patents, which is commercialized. And the protection for this particular converter, it can protect this converter itself and the connection. So that is what the two patents which is mentioned by Haris sir. Okay, now I addressed the battery life. I also addressed the amount of investment that you invest on the converter will also has come down. Now let us see how fast you can charge. So I said you should charge the bus in less than 10 seconds or 30 seconds. So in seconds, we are talking about in seconds. So when it comes to conventional charger, you have this charger, and if you want to charge this battery, after making connection, you need more than 30 seconds to start the charge. Okay, you need more than 30 seconds to start the charging. Okay, so if it happens at the bus stop, then the passenger will get irritated. You know why? So at every bus stop, first it has to connect. It may take 3 seconds or 4 seconds, and then it has to wait for 30 seconds, more than 30 seconds to start the charging, and then it has to charge for 20 seconds or 30 seconds. It will be roughly 1.5 minutes. So it is not going to work out. So why you need this 30 seconds? Because you are having a DC-DC converter which doesn't know what is the voltage rating and current rating required for this battery. So the BMS on board will communicate to this DC-DC converter saying that, hey, charger, I need this amount of voltage and this amount of current. Overall, I need this pattern of charging. I need constant voltage charging now. I need constant current charging now. So this communication should happen, and then only you can start the charging. That is what happening in the conventional. But what we have done in flash charging, we thought of using the onboard converter itself. Okay, the onboard converter which was already in touch with the BMS. So it was the one running this DC-DC converter for running this motor. So there is no need of further communication required for this rectifier, because your communication is already there in place with between this battery and this converter. So you don't need any additional communication. So it is just a plug point. Okay, so as soon as you connect, you are ready to charge. So that's how you reduce this more than 30 seconds time here. Now one issue that we have is we need to make a very fast connection. So how to do that? So the very fast connection can be done with a robotic arm installed on the bus. Okay, so it will have an RFID tag. As we all know, now toll gates are working with RFID tags. You have a fast tag, and then you go near, it will read something, and then it will open up. The same thing work happening here. So the robotic arm automatically comes out and ready for connection. So once the bus driver stops the bus and opens the door, the moment he opens the door, it will go and connect. So it will charge as long as the driver keeps the door open for the passengers to get in and get out. So that is what happening here. So let's see a video. For this is in city of Geneva. So how it works. So you can see the charging. The bus name is called Tosa. You can see the door open and the robotic arm got connected. And one more thing that you need to note here, in conventional charging, when the bus is charging, the operator will ask every passenger to evacuate at the terminal. But this is not happening here. Thanks to this patented technology of ETS, they call it as energy transfer system. You can allow the passengers get in and get out while charging. So this is very safe, and it is tested in different environment like freezing environment as well. So it is working fine. Now someone will ask me, what about the safety? Because you are saying this is a 600 volt or 500 volt DC. How safe it is? It is safe because we are making that as a passive charging pole. How we are making that? So as I said, when the RFID tag activates, then we energize the pole. So once the bus comes there, come approaching, then we energize the DC bus. That means the converter will be turned on. Then it will be ready to maintain DC bus. Once the bus charges, disconnect the robotic arm. The moment it disconnect, the DC bus will be de-energized. So it will be just a passive pole. So it is absolutely safe. Now, let's see what and all the infrastructure that you need to make this happen. So as I said, let's start with the depot. At depot, again, you need a rectifier, you don't need a charger. So in flash charging technology, the depot is meant for maintenance, not for charging. So you can have a single charger for 4 or 5 buses together, just to maintenance, just for maintenance, not for charging. You don't need charging at all, because you, when you go to the terminal, the moment you go to the terminal, you will charge to the required level. Then you reach the next terminal, you will be ready to go for the next trip. So you can run the bus 24/7. You don't need to come to depot at all. So the depot is only meant for maintenance in flash charging technology. Sometimes you may need to maintain the overhead robotic arm itself. So in that instant, if you need to have some auxiliary power supply, so you can we provide additional plug point which will directly connect to the auxiliaries. So that is why you get two types of connections at the depot. And terminal, as I said, we use thyristor bridge, charging pole, and the bus has its own charger, the onboard DC-DC converter, so it will charge. Now, when it comes to flash feeding station, that is which is available at the bus stop. So the charger available at the bus stop is called as flash feeding station. Again, see, we are not using the word charger. We are saying it is a feeding station, terminal feeding station, depot feeding station. The charger is available on your on the bus. So that is why we name it as feeding station, but not charger. Okay, so far I have never mentioned anything about energy storage. How come there is energy storage coming into picture here? So you all wonder why. Okay, let assume the city bus. Okay, the bus is running in a city where there is a distribution line of 415 volt and you want to install a charger. So which will, as I said, the power level is 400 to 600 kilowatt. So when you want to charge the bus for with 600 kilowatt in 15 seconds, sometimes the distribution grid may not be able to handle that much of peak power on its load curve. So the surrounding household appliances may see there is a dip, so they'll complain to the distribution grid and say that hey, because of this bus they are charging huge power, they're drawing huge power in 10 seconds, so we can see a dip in the voltage. So how can you allow that? So if that is the case, the first option is we skip that location. The second option, if we don't have any other option, because the next to 3, 4 stops or 5 stops are completely residential area, then we cannot do that. So we install a small battery. We charge this local battery with allowed power level. Then when the bus comes, we discharge from battery to battery. So again, there are two things here, energy and power. I'm saying that we need a low energy battery, but a high power battery. So energy is power into time. Okay, I hope you all know this. So we install a very small battery just to handle this transition because of grid compliance, nothing else. Now, what is on board? So on board, you have a traction converter, which is capable of running the motor drive as well as converting as a DC-DC converter. So this is traction chain, which will be water cooled or liquid cooled, depends on environmental conditions. Then you have a small pack of batteries, which is also water cooled or liquid cooled. So we generally use LTO batteries, that is a lithium titanate oxide batteries, so which has high C rate. So that is why you are able to charge 600 kilowatt, and the robotic arm, and you have this motor drives. So if it is a double articulated bus, then you need two motors to drive the bus. If it is a single bus, then you need only one motor. So the bus can see there is nothing inside or nothing on the chassis. Everything is placed on the top. So very small space is enough to manage this bus. That's how you get huge passenger capacity. And when it comes to any bus manufacturer, it is very easy for them to make electric bus. So they don't need to make too many modifications. Only a motor, the chassis remains same, the body remains same. Only the top of the bus we install some converter, battery and robotic arm, and bottom you install a motor. That's it. So you don't have to do too much modifications in your bus manufacturing when it comes to diesel bus or electric bus. So the design can remain same. Now, we talked about batteries, we talked about the charging stations, we talked about how can you optimize everything. But what is the impact of this uh, e-bus charging on the grid? Let's see that. So generally how we decide the voltage rating, current rating. So we all know energy formula I into V into T. That is what watt hour. So generally current rating decided by the heat losses. Voltage is limited by insulation requirement. So when it comes to more than 1 kV, then there will be high standards that which is difficult to meet. So generally e-bus are limiting less than 1000. So if it is less than 1000, why not 900 volts? So there is a reason. So even in transient you should not cross 1 kilovolt. So that is the reason, to be a safer side, generally they limit to 500 or 600 volt DC bus, they maintain that one. However, the battery voltage may vary from 900 to 200, depends on battery chemistry. So that is which will be on board. So they have their own requirements, so they will handle. But when it comes to the grid and public places, so it should be, because the charging pole will be available at public spaces, so you need to follow some standards. So that is why we generally limit this one to 500 or 600, and accordingly the current. Now the time, who will decide the time? The time is decided by the operator. He will say how long my bus should run, how long my bus should rest. So it depends on depot, how much stopping time at the depot, depends on how much stopping time that I get at a terminal, and how much time that I can stop at the bus stops. So that's how you decide the time. Now, as I said, it is estimated that 1.5 kilowatt hour per kilometer is the energy that you need for a 12-meter bus, and it is 2.2 kilowatt hour per kilometer for 18-meter bus. Again, is this valid for every bus, every scenario? No, it depends on many factors. What is your auxiliary load? What is your line profile? How your driver is driving the bus? Because we know F equal to M into A, acceleration. So if you unnecessarily accelerate, then you consume more force. You consume more force, that means you need to have more energy. So that's how it, mostly it is estimated that it is 1.5 or 2.2, but again it depends on multiple factors. Okay, now what is the impact that you get on the grid? Okay, so as I said, let us consider the bus is of 18 hour operation. The bus needs to run for 18 hours, that is roughly 250 kilometers per day. I'm assuming it is a 18-meter bus. So what is the energy that you need? 250 kilometers into 2.5 kilowatt hour per kilometer. So that will give you 625 kilowatt hour per bus. It is for per bus. If you have 100 buses, then what will be that total you need divided by 18 hours, because we are not charging the bus when it is in resting position. We are charging the bus while operating. Okay, so as long as the bus is operating for 18 hours, so that total energy required is divided by 18 hours. That's how you see a flat curve in the grid. So it is just 3.5 megawatt flat curve over 18 hours duration. But when it comes to depot charging or overnight charging, where you have only 3 hours of time to charge all the buses, then see how much power you need at the depot. You need to have a 21 megawatt power that you need. Okay, so 21 megawatt is nothing but you need to have a separate charging station. You need to bring um, medium voltage lines, 11 kV or 66 kV lines to that particular place, and then you need to step down and you need to have a huge setup at your depot. If it is an existing city, building this depot charging station with 21 megawatt is bit difficult, because you need to have extra land, then you need to lay power lines, and then coming to power utility charges. Okay, so you installed 21 megawatt, but you are using for only for 3 hours in a day. So again, you need to pay additional charges for that. Even if someone says, okay, I'll stretch it for 5 hours instead of 3 hours, still you need 12.5 megawatt of power that to be available in at your depot. So, but when it comes to flash charging, you see a flat curve. In other cases, you see a peaks in the load demand. So that is the impact. That's how we also consider the impact on the utility grid. That's how we came up with flash charging technology. The same thing with the different numbers is given here. Again, the conclusion is you will see a flat curve, and when it comes to other technologies, you will see a big peaks in the load demand. And this is what I already talked about, the wayside energy storage, why you need this energy storage. As I said, when you are in residential area, if you want to install a charger, there will be a huge dip, so it cannot handle. Then the distribution guy will say that you cannot have a charger something this much power level. So we ask them what is the power level that you can allow. So we install that much power charger and a small battery. Or the first option, as I said, we can skip that location. We can have a charging station in some other location. Now, when you want to be a very good operator, bus operator, e-bus operator, very good in the sense you to earn more profits, you have to take care of all these 5 elements. First thing, you need to maintain the timetable. So every customer should feel that this electric bus can maintain the timetable. Then you should carry more passengers but not batteries, so that you will earn money. So passenger will pay you, battery doesn't pay you. Then you should make sure that your battery life is more, because you know why. Let's say in India, electric bus cost you around 3.5 crore to 4 crore. Okay, so in that 40 percentage to 50 percentage goes to battery. So 2 crores, roughly 1.5 to 2 crores goes to battery itself. So the battery life is, we know that it is just 3 to 4 years maximum. So 3 to 4 years, again you need to invest another crore. So it will be too much for your investment. So you need to make sure you have a long life battery when you want to operate an e-bus. Now again, you need, again as I said, you need to see grid compatibility. If you install so much in the depot, then you see a huge peak demand in the grid. So the grid people may not be happy about that, and you install some charges. If it is not meeting the grid code, again there will be a problem for you. So they will penalize you, or they may ask you to completely take out your charger so you cannot run your bus. So better take care of grid compatibility. Then, as I said, you need to have a light infrastructure at the depot. So these 5 elements are very, very important to be a very good bus operator. So you need to take care of timetable. You need to take care of whether you are carrying passenger or battery, whether your battery has a longer life or not, whether you are meeting the grid codes or not, and you have a light infrastructure at the depot. So don't spend too much on the batteries. The investment that you make in the charging stations or feeding stations will last for 20 years or 25 years. It is just a converter. If something goes wrong, maybe a switch or a capacitor goes wrong, then you can replace it. But if you invest too much on the battery, then anyway the battery will go by 3 to 5 years. So you have to invest again. So choose properly. Now, I said you need to install feeding station here and there. What is that here and there? How can I get that location? I said the optimum solution depends on multiple factors. What are those factors? So how can I decide which is the best solution? So for that, there is an optimization tool which takes the bus profile. So we bus simulation in the sense whether it is a 12-meter bus or 18-meter bus. Whether what about the battery? We recommend LTO, but some manufacturer says no, I cannot use LTO. I want to use some other chemistry. So we, yeah, why not? Let's take that. We'll see, we'll understand what is that battery chemistry. Accordingly, we can plan. So we do this cost models, like what is the cost that the investment on infrastructure and everything. Finally, we do some traffic simulations, that there is a huge traffic. Maybe you need to go some other route. Sometimes you may need to take another route where you may miss some charging stations or feeding stations. So we do that sensitivity analysis as well. And finally, we come up with what is the optimum size of the battery that you need to carry. what is the location that you need to place these feeding stations, and a detailed information of how much that you have to invest, how much will be the operating cost, and finally what will be your total cost of ownership. So this particular thing is called MyTosa in ABB. So they have this tool. You give your line profiles and they'll run the simulation and they'll tell you this is what you need. So apart from technical things, you also have monitoring solution with them. So just to highlight one thing, like they continuously monitor what is going on the bus and what is going on at every bus stop. So it will be given to the customer. Now what happens is, for example, in the first bus where we delivered 12 buses, out of 12, one particular bus used to come with a low depth of discharge. So every bus used to come at 55% of SOC when it is terminal. One particular bus generally comes with 40 or 45, something like that. So we have seen that driver's driving style, how he is driving. So he's unnecessarily accelerating and decelerating the bus. So that is why the energy consumption is more with him. So you can just warn that driver, see your driving style is not so good. Why don't you change your driving style? You train the driver and then it is up to mark now. So this is how you can manage your asset. You have installed everything and you have to manage everything. So that is also available here. These are like live examples or live projects which are already running. So as I said, this is in Geneva. So where there are 18-meter buses, 18.75-meter buses. It can carry 133 passengers. And you see there are 50 bus stops between the two terminals. Out of that, only 12 chargers are installed. Okay, so not like every bus stop you need a charging. Again, it is not that if you can't charge in that particular bus stop you cannot go to next bus stop, not like that. We have seen that charging thing. We are trying to maintain that profile so that you can have a very good life. It's not like if you cannot charge at one particular bus stop you cannot move your bus. So where there is a 600 kilowatt in 20 seconds of flash charging is going on. And these are some statistics like how many passengers in a day travels, because it is running between airport and city center. So roughly more than 10,000 plus are traveling in that route. So they are earning good profits in that. And this is another city, Nantes in France, where 24-meter buses are there. 22 buses are delivered. You can see here only 6 out of 34 bus stops. See, we delivered 22 buses. How many chargers we installed? 6 plus 2 in 2 terminals. So 8. Only 8 chargers. 8 feeding stations, not even chargers. That's it. So if you go for depot charging, you need to purchase at least 22 buses may not be enough. See the frequency. At every bus stop, you need to see 2 minute 45 seconds is the gap. Every 2 minute 45 seconds, there should be another bus coming up. So you cannot manage that with 22 buses and 22 charges. You need to purchase more because the bus needs some charging time. Okay. This is another project in Australia where they ordered 60 buses of 24 meter. The analysis was under study before I left ABB. I think they are still doing it. I'm not sure. I'll check with them. So, which can carry more than 155 passengers. And they asked us to see there is every bus in 3 minutes. So, to conclude, the flash charging technology has world's fastest connection. You can connect the bus, you can connect to the feeding station in less than a second. Full system view. It's not like we sell a product and you use it the way you want it. So we take care of battery life, we take care of profiles, how far you can maintain your timetable, a full system view, whether you are able to meet grid code or not. If you are, as I said, installing a batteries in particular locations at the feeding station. So, and there is a simple interface. There is no need of communication protocols at all. So you can charge the bus as soon as you can connect. As I said, we are just installing a rectifier but not a charger. Then the only system available for high passenger and high frequency lines. So no other technology can meet this kind of high frequency and high passenger capacity lines. And a common system for all the lines. For a common system in the sense, as I said, For example, there are 12 buses running in a route. The charges in that particular route are meant for that particular route. So you can get any other electric bus and try to run in the same route. It doesn't make any difference, because the energy required in that particular route is available in the route itself. Whatever the energy that you need to run the bus in that particular route is available in terms of feeding stations here and there. So you don't have to worry about changing the bus routes. One day one bus can go in this route, the next day the other bus can go in another route. So that is absolutely no issue with that. So that's it about flash charging technology. I thank you everyone for your patient listening, and I hope I was clear, loud and clear, and I was not running. Thank you. Hello.
Yes. Thank you, sir. If you have any questions, please unmute your mic and you can ask the question.
Hari sir, I hope there was no interruption, something like that, right? Hello.
Yeah, there was a hand raised by somebody.
Let me check.
Was he? Yeah.
I cannot check, I think. Only the organizer can
Yes,
check
actually,
who
I
has
am
raised.
checking for that, but it's not there right now. Somebody
Uh-huh.
is in the initial stage of your presentation, but I couldn't see
Okay.
it right now.
Okay. And I don't see anything in the chat also. Maybe I cannot see.
So, Reddy Garu, I am Dr. Jain. A
Hel-
very fine study and kind of project which is live working now, and good amount of information on flash charging.
Thank you,
We
sir.
were always thinking that there should be definitely an alternate to bulk charging or kind of thing. But is there any suggestion from you how we can implement similar things? It's not possible for cars, I mean personal passenger vehicles, because cost of battery, if it can be reduced like you have done in your case, definitely it will be a great advantage or commercial advantage for commuters or people who are using e-vehicles tomorrow.
Yes, sir. As you said, you cannot use the same technology
Yeah, I know.
for cars.
Yeah, yeah,
Yeah.
because there it is point to point.
Yes. So
Mm,
we know the route is fixed, so that
yeah.
is why. But again, as I said, if your electric buses are well in place, and who will use their own vehicles, because they are using their own
That's true.
vehicles for
That's
their
true.
comfort.
Yeah, if it is a public transport is available, nobody
Yeah,
prefers to use their own vehicle.
their own vehicles.
That's
Yes.
true. That's true. Any development in battery technology?
Battery technology, actually, LTO so far is
Hmm.
better from our analysis. So we also analyzed super capacitors, also use of super capacitors as well. For now, we felt LTO is better, but I think there are some battery manufacturers and some universities are coming up with active anode change of something. So instead of using fixed anode, you
Hmm.
can change the anode actively when it
Okay.
is fully packed up with electrons. So some things are coming up. Again, I'm saying that's what I so clearly
Yeah,
pointed
it's
out.
only in development phase.
Yeah, batteries in development. Tomorrow you can get a very good battery for cheaper rate. So why to invest so much on battery now?
I read somewhere now people are thinking of semi-conducting batteries.
Yeah,
Um,
that is also
yeah,
there.
this is
Uh,
recent publication or paper published very recently, maybe a month back or so. So
yeah,
this
I heard
2025
about
will
that.
have much lighter and much
Yes,
kind of high energy density batteries, which are
yes.
not based on any kind of chemical reaction and things like that.
That's what battery technology is evolving. So why
Yeah.
to invest so much on batteries?
So over to you, Hari.
Yeah,
Hari.
Yes, sir. The CS sir, see the chart window. There is one question in the chart.
I
If
cannot
there
see
is any.
the question posed by I mean, I can only see what I can type.
Okay.
Could you please read out the question?
Yes, sir. The question is, instead of having multiple charging station, can we have multiple batteries and less charging station to save on cost? Like we
That
put
is
petrol.
that is nothing but battery swapping technology. Again, you are investing a lot of amount in the battery, right? So it's again investing a lot in batteries. So instead of one battery for one bus, you are purchasing more batteries for single bus.
Okay.
So it is very clear that investment on battery is more, and it is going to be a waste after 3 to 5 years. So our suggestion is invest more on infrastructure, that is rectifiers and DC-DC converters, which will last for 25 years.
And the question is, as we put
No,
petrol or diesel for car, can we replace battery at specific point? I think he wants to
Okay, if the
simply replace
question
that instead of
the
charging it.
if the question is something related to replacement of, I mean, um, existing vehicles into electric bus, is that the question, or is it something same as battery swapping, having more batteries?
What I understood is that instead of recharging the battery,
Mm-hmm.
okay, simply replace the discharged battery with a charged battery,
That is
so that
again, so
you
it's the
don't need
same
to
thing,
wait for.
right?
Mm,
Yeah, it's the same thing. You, instead of one bus one battery, you are purchasing more batteries. So if you want to purchase one electric bus, if it is 3 crore, 1.5 crore is for one battery. If you want to purchase another set of battery, then it is 4.5 crore.
now again,
and
information, a small information here. This swapping of batteries, charged batteries. Somebody is coming up with a kind of enterprise where a car battery is taken out and a charge battery is given to him at a cost of charging only, but it is only for personal vehicles, not for buses or anything else. It is only
Um,
for, it's a
no,
combination. Yeah, yeah, for
buses are also
buses.
there
Yeah.
in Ahmedabad. There is one bus running, battery swapping for a bus. So
Hmm.
you need to have a huge setup of robot, all robots like big robotic arm coming in and then taking out the huge battery, which is
Battery,
of 4.5 tons of battery. You need to take it out and take it in. So that is, see, I mean, again, the company says that we invest on batteries, we charge you only for the amount of charging. So that is fine, to an extent it is fine, but when it comes to environmental impact, again someone is investing a lot on batteries.
very correct.
So
yes, sir, there is one more question from SMVB Rao.
uh-huh.
Uh, Participants, can you please unmute your mic and ask yourself? Because if I read it, I may convey it wrongly.
Hello,
Yes, sir.
sir. This is SME Brahmareswara, sir.
Okay, sir.
Sir, I am having a small question. Maybe this is very silly to you,
No, sir, any
sir.
question
Like,
cannot be silly.
sir, we are using different cell phones with the
Okay.
different manufacturers and with different chargers, charging.
Mm-hmm. Mm-hmm.
Now, just you told me that e-buses are all having onboard chargers, right, sir?
Yes.
So, but still, buses will be manufactured by different manufacturers. How can buses will charge themselves with this
Sir, I
at
cannot hear
onboard?
you properly. Can you please repeat the question?
Okay,
Maybe
sir.
there is a
Sir,
huge
actually,
wind.
okay, sir. Sir, actually, different manufacturers are there, sir, for manufacturing buses,
Mm-hmm.
e-buses.
Mm-hmm.
How can all the buses will use the same single charging point like cell phones?
Okay, if everyone can use their motor drive as a charger, then we can just have a rectifier so that anyone can use.
Okay, sir.
As simple as that.
Okay.
And again, because if they have their own charger with them, that charger knows what is the voltage rating and current rating that is required for that battery installed in that. Whether the chemistry may be different,
Okay.
but the onboard charger knows what the battery wants. So
Okay.
it can just take that much power available from the only thing is the rectifier should be properly rated. That's it. If the rectifier is rated
Okay.
for 500 megawatt, 500 kilowatt, you can charge the bus of 200 kilowatt or 300 kilowatt or even 100 kilowatt or 50 kilowatt, whatever it is.
Okay. Sir, one more thing, sir.
Yes.
So you have stated one point that driver is also very important, essential
Yes.
thing.
Yes, sir. Yes, sir.
But how can we implement those type of driving skills in India?
See, one thing is, as I said, traffic simulation. The traffic itself may be bad, so that the driver cannot do anything. One thing.
Okay, sir. Okay.
Second thing, though it is a very good traffic, but still he is just, for example, instead of, we can clearly see that there is a bus stop in 10 meters, but still he will
Okay.
accelerate, and
Okay.
then he will go there and put a sudden brake.
Okay, sir.
So it doesn't make any sense, right? So
Okay. Okay. Okay, sir. Thank you.
yes.
Yeah, good morning, sir.
Good morning, madam.
We are very glad with your information, sir. And my doubt is that this technology is not applicable to cars and vehicles which we are using, like a motorbike. I mean, that means the complete technology changes, or else that similar things can work out there.
Similar things can work out, madam. You can try your mobile charger. Don't charge it completely 100%. Charge it till 90%, and then when it comes to 50%, you charge it again. You see the life of the battery. You can see a change. So again, for example, if you have a car, if let's take an average life of a city life. So how long you drive in a day? Maybe you take a house in 10 kilometers away from your office. No one goes beyond that. So roughly 10 kilometers. So for 10 kilometers for a car, you need how much energy? Roughly like for 1 kilometer, it will be 200 watts or 300 watts. So for 10 kilometers, you need just 3 kilowatt. So 3 kilowatt, instead of having very big battery, so you have a let's say 25 kilowatt hour battery. Okay, so in that you consumed just 3 kilowatt. So after going to your office, you charge the 3 kilowatt again. So but maintain that charging profile is in that range. But when you are going for a long drive, you cannot do anything. Either you need to increase your battery capacity, or you need to see that there is a charging station available at some location. So what I'm saying is, for an employee staying in a city, average in a year he can travel only three or four instances that go for a long drive. For rest of the days he will be just traveling 10 kilometers or 20 kilometers. So it will work out. You can have a longer life battery with this kind of. You see that, you are the one planning, right? Your car. Bus means it is planned by operator. Your car, you can plan it. So let's say I'm not going to anywhere, I'm just going to office. So let's see, my battery is 90%. Then I start with 90%, go to my office. So it will come around 60%. Then from 60% to 90%, I charge it in my office to 90%. So you have anyway, most of the electric vehicles are coming up with smart technology, so you can see in your mobile what is happening with your battery. At 90% you be in the office, you just click one button, you can stop your charging at 90%.
Okay.
Yeah.
And one more doubt, sir. That means you mean to say that actually, as per our knowledge, what we think is that if we use the complete, that means how much we discharge the battery, the lifespan of the battery will be increased. Is that is true or wrong?
Wrong, madam. The depth of discharge, the deeper you discharge, the life is less.
That means, for example, if the mobile battery was discharged for 50%, then again we have to charge it immediately. We should not wait until it reaches to the 9%, 8%, you mean to say?
Yes, madam. But because it is a mobile phone, you cannot carry charger here and there. So
Yes.
generally we charge it completely. But I suggest at least don't go below 20%. Whenever the battery says low battery, don't use that. At least try to charge it.
Fine, sir. Thanks. Thank you, sir.
And also, when it comes to mobile phones, you might have purchased one charger which says that 1.1 ampere or 2.1 ampere. So you can see that there will be two ports available in any USB charger. So
Yes.
you make sure that your mobile phone is okay with that 2.1 ampere. As I said, fast charging or slow charging depends on how much current your battery can accept. For
Okay.
example, if the charger given by the mobile manufacturer says 5 volt 1.1 ampere, then if you connect 2.1 ampere charger to that mobile, you can see there is a lot of heat going on with your mobile.
Yes.
The same thing applies to the cars. Like now you can see any petrol bunk, there is a power petrol, normal petrol. So you have to check with your manufacturer of car manufacturer whether, because that will generate more heat. The power petrol will generate more heat. So whether that heat is supported by your car engine or not, that you need to check. Don't go with everyone says it gives greater mileage, but greater mileage because with less amount of fuel you get more amount of heat. That is what happening. So the more amount of heat, say, in the sense the car engine should be capable of holding that, withstanding that heat. So whether you need to check whether it is possible or not, then only you go with power petrol. So
Okay. Thank you.
thank you, madam. Hari sir, any other questions in the chat?
No, sir, I don't see. One question is this: any additional information regarding optimal placement of charging station?
Yeah, that there is a tool called MyTosa with ABB. It works as simple as this. See, I want to maintain this charging SOC, rate of SOC, state of charge. So I need to start with 90%. I need to end my trip with 60%, so that I can recharge back from 60 to 90 within given time. Let's say 3 minutes. In 3 minutes, 60 to 90, I need to get back my full charge, 90%. Again, with you see any charger available in the market, slow charger generally of rating 10 kilowatt or 20 kilowatt. Fast charger, they say it is 150 kilowatt. So what does that mean? So you are just increasing the power to reduce the time. That's it. So there is nothing magic in converters. It is just power level. So you are changing the power level, but that power level should be accepted by your battery. So 150 kilowatt hour, let's say 600 kilowatt charger with 600 volt DC. That means it can inject 1000 amperes into the battery, right? So whether the 1000 amperes can be accepted by that battery or not, that you need to check. That's it.
Right, sir. I think no more questions left.
Okay.
Thank you, sir. It's a wonderful lecture. You have covered many practical issues also. Even you have discussed about the timetable organizations too, which I didn't see in other presentation. And one more thing, sir. I apologize for my mistakes I pronounced during your introduction. I think mentioned it as you are working in IIT Trichy.
Yeah, and I did my PhD there, and then I went to
Uh,
postdoc. Yeah, no issues with that. So I do
okay,
apologize.
anyway, thank you, sir. We'll be waiting to see you again tomorrow for the next session.
Yeah. And
Uh,
tomorrow we'll be discussing about microgrids again, AC microgrid. So thank you for your patient lecture. There are no questions. I don't know whether everyone understood it very well or they don't want to ask anything.
No, sir, I think they understood well because even I've been following your presentation. So you have covered many points, maybe probably equivalent to reading maybe 10 to 15 research articles also.
Oh, thank you, sir.
Right. Thank you, sir.
Thank you.
Bye for today. We will see you tomorrow again.
Yeah.
Thank you, participants.
Thank you.
Thank you, everybody. Bye bye.
Thank you, sir. Thank you, sir.